Yes, good morning all of you. I hope you all are safe at home. Okay, anyway, we will first of all we will discuss in second PUC. First topic is nothing but the solid state. Okay, the weightage of solid state in board point of view, 7 marks we will get. Out of 7 marks, we will get one 2 marks question and as well as one 5 marks question we will get. Okay, this is the weightage. Everybody should understand very carefully. It's a very important as well as board and competitive point of view. So first of all, we will discuss about some important things regarding solid state. First of all, what is the meaning of matter? Do you know matter? We are in first year. The matter means is the things which has space and occupies volume, and mass is calling as a matter. So matter means things which has mass and occupies a space are calling as a matter. Mainly matter will be classified into 3 categories like solids, liquids and gases. In first year we already learned about the liquids as well as gases and states of matter lesson. States of matter. Okay, now in second year we are especially discussing about the solid state. Okay. Now first of all we will discuss about the characteristics of solid state. Characteristics of solid state are nothing but solids. So what are the special characteristics or properties of the solids? First of all, in this solid matter, if you consider the constant particles, they are very closely packed together. Very closely packed together. Why they are very closely packed together? Because of a strong force of attraction between them. Strong force of attraction between constituent particles. Those strong force of attraction only we are calling as intermolecular force of attraction. Intermolecular force of attraction. That intermolecular force of attraction should be high in case of solids. Okay, next thing you have to see, due to this one what happening, the constant particles are very tightly packed together like this. Such kind of matters only we are calling as a solids. Now, due to this very close packing, if you can absorb any 2 constant particles in solid case, the distance between the nucleus of the 2 closely packed atoms is nothing but internuclear distance. Internuclear distance. In case of solids, internuclear distance should be very short. Why? The constant particles are very closely packed together, that's why the distance between the nucleus of the 2 closely atoms should be very less. That's only we are calling as internuclear distance will be very short or small. And these solids are having definite, you know very well, they are having definite mass, shape and as well as volume. Okay. And we have to discuss one more point. In case of solid matter, the constant particles are having any moving nature? No. Means in the solid matter, the constant particles are having fixed positions. Having fixed positions. So means they can't move. That's why the constant particles are having a definite or fixed positions. Later we have to discuss some other characteristics of the solids is nothing but they are highly rigid bodies, highly rigid bodies, means they are very strong materials, and due to highly rigidity, and they are also having high melting point. Yes, first of all, what is the meaning of melting point? If you take any solid matter, you are keep on heating, what happening at a particular temperature, it should be converting into which one? Liquid matter. Such temperatures only we are calling as its melting point. So if you take that particular temperature only we are calling as its melting point. Why melting point of solids will be high? In case of solid matter, constant particles are very tightly packed together because of strong force of attraction. If you want to convert that one into liquid, we should break the force of attraction between the constant particles. So this process requires more energy. That's why melting point for the solids will be high, and they are having high density. They are having high density. Okay, what is the meaning of high density? You know, density is equals to mass by volume. So why the solids are having more density? If you take the solid matter in a very small area, so many constant particles will be arranging. Means in a particular unit area, more number of particles will be there. Whenever more number of particles will be there, corresponding mass will be high. If mass is high, automatically density will be also high. And we have to discuss one more thing. They are highly incompressible substances. Highly incompressible substances or matter. What is the meaning of highly incompressible? Just you take one solid matter here. Yes. So now this is the solid matter. If you apply any pressure of force on it, is there any change in its shape or volume? No. That's calling as incompressible. So there is, after applying the pressure on the body, there is no changes in its volume or shape. That's why it's calling as highly incompressible matters. All of you got clarity regarding this one? Yes. Now we will discuss about we will discuss about the classification. One of the 5 marks question in this unit is nothing but the classification of the solids. Classification of solids. How we are classifying the solids? What are the factors here? Based on important thing. Based on nature of arrangement of constant particles in solids. What are the criteria here? Based on nature of arrangement of constant particle in the solids, they will be classified into 2 categories. What is the first one? Under this one, it is nothing but first one is the crystalline solids. Crystalline solids. Second category is nothing but amorphous solids. Amorphous solids. Okay, he will ask like a differences between crystalline solids and amorphous solids, like a farmer's question. First of all, we will discuss about the crystalline solids information. Crystalline solids. So under these crystalline solids, for the first point, in case of crystalline solids, the constant particles are highly orderly arranged. Highly orderly arranged. Okay, what is the meaning of highly orderly arranged in 3 three-dimensional, in 3 dimensions. Okay, highly orderly arrangement of constant particle in 3-dimensionally is calling as a crystalline solids. Due to highly ordered arrangement of the constant particle, they are having definite shapes. They are having definite shapes. Just I will give you one example for you. If you take AB is the crystalline solid. Okay, what is the meaning of highly ordered arrangement? In this, constant particles are what? A and B. So, what is the highly ordered arrangement? For example, AB like this. Alternatively, all its constant particles will be arranged. That is only we are calling as a highly orderly arrangement of the constant particles in 3-dimensionally. That's what we are calling as crystalline solids. Okay, due to this one, we have to discuss these crystalline solids are having a sharp melting point. What is the meaning of sharp melting point? For example, I will give you one example. If you take NaCl is the solid substance. If you keep on heating, what happening at around 801 degrees Celsius temperature, the NaCl will be converting into molten state. Means if you take the solid substance, keep on heating at a particular temperature, it's suddenly converting into a molten phase. Such temperature only we are calling as melting point. It will be at exact point. That's only we are calling as sharp. And later we have to discuss about some other factors. So these crystalline solids, if you can take, okay, with the help of a sharp tool. If you cut this crystalline solid, what happening after cutting the cutted area will be smooth. We are getting a smooth surfaces. We are getting smooth surfaces. We are getting. Why? Because in answer question, why in case of crystalline solids are having smooth surfaces? Because of highly orderly arrangement of the constant particles. And next we have to discuss these also having definite value of enthalpy of fusion. Enthalpy of fusion. Yes, the very important point we do learn in thermodynamics. What is the meaning of fusion? If you take the solid substance, keep on heating, it will be converting into which phase? Molten phase. Yes or no? Means the energy which is required to convert a given solid substance into molten matter or liquid matter is calling as enthalpy of the fusion. Regarding crystalline solids, those enthalpy of the fusion value should be fixed or definite. Why? Because just you see, in case of this AB crystalline solid, wherever and whenever you take, the constant particles should be arranged in the same order. If you want to disturb them, required energy will be always should be fixed. That's only we are calling as definite value of enthalpy of the fusion. These also calling as a true solids, means a perfect solids. Just I will give you one more some example for this category is nothing but sodium chloride, potassium chloride, zinc oxide and cesium chloride, like metals we can take, and also quartz. Quartz is one type of the material, and we can take alloys. These all are example for the crystalline solids. Under crystalline solids, we have to observe one important character, last and very important one, anisotropy character. Anisotropy property. What is the meaning of anisotropy? Isotropy means what? Same. But anti means opposite, means indirectly meaning is different. Yes, what is the different here? We have to check it. For example, you take AB is the crystalline solid. In this, what is the arrangement of the constant particle? AB like this. Yes or no? Yes. Now you consider some of the physical properties like refractive index. Some of the physical properties of the solid material is nothing but refractive index denoted by mu. And we can consider a conductivity property also. Conductivity denoted by K. If you consider any one of the physical property in a particular direction, you see here. For example, I am considering refractive index in this direction. In this direction, only which particle is coming? A particle is coming. Then corresponding value will be mu A. I am considering another direction like this. In this direction, only which particles is joining? B particle. Then refractive index related value will be mu B. Is it equal? No. Here mu A because only of A particle. Here mu B because of only B particle. They should not be equal. Means that's what he is telling. Anisotropic character means if you consider some of the physical properties in different direction, we are getting different values. That's calling as anisotropic. Once again, if you consider some of the physical properties like refractive index and conductivity values will be giving different values in different direction for the same crystalline solid, that only we are calling as anisotropic. All of you clear? Yes, this is the crystalline. What is the meaning of crystalline solids? Constant particles are highly orderly arranged in three-dimensional. They are having a definite shape and they are having sharp bending point. After cutting the bodies with sharp tool, we are getting smooth surfaces and they are having different value of enthalpy of fusion. They are also calling as true solids. Regarding crystalline solid, if you consider any property in different direction, we are getting a different value. That only we are calling as anisotropy. Yes, clear? Yes. We are discussing about the second type of solids is nothing but amorphous solids. Amorphous solids. Okay, what is the meaning of amorphous solids? In these solids, the constant particles are irregularly arranged. Irregularly arranged. Means in three dimensions. Mathematically, what happening? They do not have definite shape. Definite shapes. This is the reason. Amorphous solids are having irregular arrangement of the constant particle. Due to that reason, they do not have definite shapes. And I will give you one example. You can understand. For example, PQ is the amorphous solid. Irregular arrangement means there is no proper order of those constant particle arrangement. For example, P, Q, P, P, Q, again P, and again P is there, again Q will be there. Is there any proper order of arrangement of particles? No, one P, Q, again 2P, like this will be there. This is only we are calling as irregular arrangement of the constant particles. That is calling as amorphous solids. If you take like these solids, we have a range of melting point. What is the meaning of range of melting point? For example, understanding purpose, I am giving one example. Plastic is an amorphous solid. Actually, it is in solid phase. You started heating. Is it converting suddenly into liquid? No. So the melting, yes, you take a plastic, you start heating, slowly what happening? Converting into liquid when at X degree Celsius. Okay, still you keep on heating. What happening? After reaching Y degree Celsius, the total plastic will be converting into liquid phase. That's what we are calling as melting point. Finally, the plastic will be converting into liquid phase. Is it exact value? No. Between two different temperatures, the total melting process is going on. That's why it's calling as a range of melting point. And we have to discuss here some important things. If you take like this amorphous solids, yes, with sharp tool if you cut that one, after cutting what happening? We are getting a rough surfaces we are getting. Yes, I am asking one question, why we are getting rough surfaces? Because of irregular arrangement of the constant particle, we are getting rough surfaces. And one more thing is nothing but not definite value. Not definite values of enthalpy of fusion. Why they do not have definite values of enthalpy of fusion? Yes, if you take this PQ crystal only, it is amorphous solid at a particular condition, this is arrangement. If you change the conditions, what happens? The arrangement may change. Automatically, what happens? To break the substance, liquid energy may also changing. That's why we are telling it does not having different values of enthalpies of the fusion. And later we have to discuss one more thing. It is also calling as pseudo solids. Pseudo solids, also calling as super cooled liquids. Super cooled liquids. What is the example for this one? His best example is nothing but glass, plastic, and rubber, and as well as starch, and so on, etc. These all will undercome amorphous solids. Okay, here important character is nothing but these amorphous solids are having isotropy property.